Right, we are considering about Newton's law of motion. What's that? Newton's. Right, Newton's what? Newton's law of motion. Newton's law of motion. Right. We know that most of the students know that there are three main laws introduced by Newton, but the most important law and the most useful one is F equals to ma, or the second law. We know that other equations are also important and other things are also important, but the most important thing is second law, because it's about momentum. F equals to ma. This is coming from the Newton's second law. Okay, why I am telling that this is very important? Because for most of the calculation purposes we are using Newton's law of motion. That's why I am telling that Newton's law of motion. So not actually Newton's law of motion. Newton's second law of motion is the most convenient equation for most of the calculations part. Okay, let's consider about how this F equals to ma existing, or how this is coming. But yeah, okay, if there is a mass which is initially going with the u velocity and its final velocity, if the final velocity is v, so the mass isn't going to change. So m is m in the two instances. This is the first instant and this is the second instant. In this linear motion, it's not going to change its mass, so it is m. Newton saying that F, or the force, is directly proportional to the rate of change of momentum. How to write that? M v minus mu divided by t. Why we are using t? Because we are using t because it's a rate of change, right? We want to do some simple calculation to this now. Let's do it. F directly proportional to m v minus u by t, because m is a common factor, so we can get it out. Now F is directly proportional to m within brackets v minus u divided by t. T is time, v is final velocity, u is the initial velocity, m is mass, and the F is force. So F is equals to k times m v minus u by t. We can write it. How can I write this k? K is a constant. We know that if we are eliminating the directly proportional sign, then we want to use equal sign and also a constant. We cannot eliminate the proportional sign without introducing a constant with the equal sign. In order to eliminate this, you must come up with equal sign and the k. Okay, but if you are substituting SI units for all of these, then this k will be a 1. So if you are using SI units, then this k will be a 1. Okay, when you are using SI units, this k will be a 1. So considering we are using SI units, we can write it as f v minus u divided by t. Now the equal sign, no proportional sign here. If you consider about this part, v minus u by t, this is some sort of rate of change of velocity. Rate of change of velocity can be also said as an acceleration. So F equals to m into a. This is the Newton's second law. This is how the Newton's second law is coming. Okay, right. Then we need to go through some calculation parts. But if I say some important things for you, we can use this F equals to ma also for helicopters, because we know that if we want to fly from a helicopter, then there should be a force acting by air particles, and that force difference will be the only thing which going to give a heads up or give the power to power up the helicopter and go to the sky. So air particles and the force difference, these are a must to do those things. And also this Newton's second law of motion significant for your Bernoulli's equation. If you know about Bernoulli, then Bernoulli's equation is also some important thing, but now we are not going to deal with that.